I don't want to waste you guys' time. We'll get right into the comparisons and then give a whole bunch of final thoughts and details at the end. The point of this video is looking at the $400 to $500 pricing segment between Nvidia and AMD in this current generation in the latest games. Unreal Engine 5, several games tested, different resolutions, different settings, ray tracing on and off, upscaling, using it, what kind of performance are we getting? Let's go ahead and just jump into the testing and I'll give you final thoughts at the end. We're gonna start by looking at several Unreal Engine 5 games because, like it or not, this will be the graphics engine of many upcoming AAA games over the next several years. And Immortals of Aveum is one of our first chances to take a look at a AAA title, leveraging Nanite, Lumen, all of that. And here we have 1440p Ultra settings, and the 4060 Ti cards are not really able to handle this, at least at above 60 FPS. They're down at 39 and 40 respectively, which means we're not going over 8 gigabytes of VRAM, they're just not powerful enough. The 7700 XT bumps up 30%, but that still only gets you to 52 frames per second. So for a native 1440p Ultra 60 frames per second here, you do need the 7800 XT. But what if you don't play at native resolution? What if you upscale? A lot of these games with Unreal Engine 5 seem to be kind of designed with that in mind at this point. And here I will say that DLSS does have the image quality benefit in motion here. It does look a little better, yeah, especially quick motion, things like that. But anyway, now the 4060 Ti's are able to hit over 60 FPS, but the 7700 XT is still 24% faster, giving it 77 frames per second, and the 7800 XT hitting 91 frames per second. So that's going to be the one that's, for me in a faster paced first person shooter type of thing, that 90 FPS range is certainly where I would want to be. Now, if we go down to 1080p resolution, the 4060 Ti's feel a lot more at home at 1080p Ultra, hitting around just shy of 60 frames per second. And the 7700 XT bumps up 31% to 76 frames per second. And then we get an additional 16% on top of that to get up to 88 frames per second on the 7800 XT. So this is an extremely demanding game. Even at 1080p, again, the 4060 Ti's are a little bit shy of 60 frames per second. There can even be more demanding areas of the game with combat, with a bunch of enemies and particle effects flying around. So, yeah, Unreal Engine 5 can certainly stress test some GPUs. However, if we do enable upscaling again, by the way, we could have turned down settings, but honestly, the graphic settings of this game are not super scalable. Several new games do seem to rely on upscaling for the majority of your performance tuning, like it or not. And so here we are, 1080p Ultra, DLSS, and FSR2 quality. Now the 4060 Ti's are over 80 FPS, the 7700 XT is over 100 FPS, and the 7800 XT is over 120 frames per second. So definitely still a big frame rate lead for the AMD GPUs here, although again, especially at the lower resolutions like 1080p, I do feel like the DLSS image quality is a bit better. This isn't really the best image quality test as far as, the way these four-way split screen is going here, but anyway, let's hop over to another Unreal Engine 5 game with Remnant 2. These are the 1440p Ultra settings, and here, once again, we see the 4060 Ti's can't handle it. This time they're in the mid-40s, and we jump 34% to the 7700 XT, hitting just shy of 60 frames per second. But then we get an additional 25% jump from there on the 7800 XT, jumping to 74 frames per second. And so, really, that's the only one that seems to be... well, I mean, the 7700 XT is not doing too bad here, too, either, at 1440p Ultra, but the 7800 XT definitely a higher frame rate experience. And once again, there's not a huge amount of scalability from low to ultra settings here, but the upscaling, these developers actually even were quoted around the game's launch time saying this game was designed with upscaling in mind. Anyway, however you feel about that, if you kick it on, we do get a healthy performance boost, and the 4060 Ti's are averaging 68 frames per second. Again, this game does not seem to show any advantage to having more than 8 gigabytes of VRAM. You jump an additional 21% performance to 82 FPS on the 7700 XT, and then an additional 22% from there, going up to 100 frames per second on the 7800 XT. Let's go ahead and look at 1080p resolution, where at Ultra, the 4060 Ti's are in the upper mid-60s, And the 7700 XT jumps 28% from there up to 86 frames per second, and we gain an additional 20% from there to the 7800 XT at just a little over 100 frames per second. Interesting to note that Remnant 2 does use nanite, but Immortals of Aveum used nanite and lumen. And I believe Remnant 2 has the virtual shadow maps turned off now on their Ultra preset, whereas at launch they were turned on. They've now split that out in the graphic settings menu. I also think in the last couple of days there may have been another patch that actually even changed things up a bit more with some lower scaling. I saw a news article about that, but this testing was done kind of first week of September when I was doing the 7700 XT and 7800 XT testing. Anyway, 4060 Ti now hitting 88, 89 FPS with 1080p Ultra with upscaling at the quality setting. And the 7700 XT up 15% from there at 102 FPS and 20% gained from there to 122 FPS on the 7800 XT. Once again, especially at 1080p resolution, I feel like things like the foliage and disocclusion as the character's arm moves and swings, things like that look a little bit better at with the DLSS rather than FSR upscaling. Now, the last Unreal Engine 5 game we'll take a look at here is Layers of Fear. This one came out before the other two and only features Lumen. However, this one, unlike the other two, lets you toggle between hardware accelerated ray tracing on the Lumen versus the software ray tracing version of Lumen that they used on the other ones, which can now benefit the Nvidia GPUs a little bit more. So at 1440p high, and by the way, this game doesn't go past the high preset, high is the highest, and then with the hardware accelerated ray tracing on, we see the 4060 Ti's over 70 FPS, and the 7700 XT right there with them. The 7800 XT, a 23% gain up from there. The other three were pretty even. But what if we turn off the hardware accelerated Lumen and go back to the software-based version of that? Well, the 4060 Ti's gain a few FPS. They're at 73 and 75 now. And the 7700 XT is at 79. So slightly ahead now, but only by 5% from the 4060 Ti 16GB. And the 7800 XT is 23% ahead, up there at 97 frames per second. So versus the other Unreal Engine 5 games, I feel like this one is a lot more Nvidia favored compared to the other two, even with the hardware accelerated ray tracing turned off. But also in general, the frame rates are a lot higher. At 1440p at the maximum settings here, all of the GPUs were well over 60 FPS. If we drop down to 1080p maximum settings, which is high with ray tracing enabled, we're now seeing every GPU over 100 frames per second, and once again, we're seeing the 4060 Ti's and the 7700 XT all at basically the same exact performance. Whereas the 7800 XT is 19% higher, giving us 124 frames per second. But they're all doing extremely well here. I think one interesting thing to note then about this is also just that it's not Unreal Engine 5 itself that needs to be incredibly demanding. It depends on what you do with it. But it certainly looks like the GPUs, the games that choose to use features like nanite really heavily are seeming to be more demanding here. Now we're looking at 1080p again, but with the hardware accelerated ray tracing turned off. And again, it does give a boost to performance, but they were already over 100 frames per second. So I think you would have been fine leaving it on. And now the 7700 XT is 3% faster than the 4060 Ti 16GB, but again, it's not that big of a difference. So it really doesn't seem like the hardware accelerated Lumen, at least in this scene in this game, is incredibly demanding, so it doesn't seem to be swinging things one way or the other too badly for the AMD versus Nvidia matchup here. And again, overall, this game versus the other two were a lot more, was more Nvidia favored, but you want to see an AMD favored game, take a look at Starfield. This was tested around when the game first launched, September 1st. And at 1440p Ultra, and the game defaults to having FSR on, but I've turned that off, as well as turning off variable rate shading to avoid any weirdness. The 4060 Ti's are only good for 37 FPS in New Atlantis, which is one of the more demanding areas of the game, but not even the most demanding area of the game. Many parts of the game do perform a lot better, though. The 7700 XT still can't handle 60 here, it's at 50, and the 7800 XT will get you to 66. But definitely massive leads for the AMD GPUs over their Nvidia counterparts here. Now we're looking at the actual Ultra preset, which does include FSR upscaling set at the 75% resolution scale. That is enough to bump the 4060 Ti's up to around the mid-40s, but we still get a 30% performance lead for the 7700 XT hitting 57 frames per second, and a 33% jump from there on the 7800 XT going up to 76 frames per second. Now, I am using FSR on the Nvidia GPUs here because this game does not feature DLSS. That was a whole big thing we don't need to get into here. However, I will note that there is various DLSS mods that can be installed in the game, and that's something you could look into, but I don't test games with mods enabled for GPU benchmarking. Anyway, so if we go down to the high preset, but go back to native resolution with no FSR upscaling, we get similar to performance to what we saw on the Ultra with FSR at 75%. The 4060 Ti's are in the mid-40s, the 7700 XT is at 57 FPS, and the 7800 XT is at 77. Also notice that we're not seeing a big difference at all between the 8GB and 16GB 4060 Ti's, so this is yet another game where it seems like 8GB is plenty. At 1080p resolution, going back to the Ultra preset with upscaling turned off, we see the 4060 Ti's in the 46 and 47 FPS, and the 7700 XT is able to hit 61 FPS at 1080p Ultra in this game with no upscaling. The 7800 XT jumps up another 30% to 79 frames per second, so big healthy lead over the 7700 XT here as well. Now, again, this game is just incredibly demanding and does seem to be very AMD favored. So do take that in mind if this is going to be the next game that you spend, 2,000 hours in like you did with Skyrim or something like that. Anyway, 1080p, if we go down to the high settings rather than Ultra, the Nvidia GPUs do a lot better. It's especially the Ultra shadows that don't work really well on the Nvidia GPUs as of launch. At the high preset with FSR and VRS off, so native resolution, the 4060 Ti's are good for just short of 60 FPS here, kind of upper mid-50s. The 7700 XT is 25% faster at 71 FPS, and then the 7800 XT gains 24% over that at 88 FPS. Yeah, let's go ahead and jump into some other recent releases. How about Baldur's Gate 3? 1440p ultra settings, all of these GPUs do very, very well. The 4060 Ti's are at 91 and 95 FPS respectively. That's only a 4% difference, and the 7700 XT is a 22% jump from that at 116 FPS, and then a 19% jump from there gets you to 138 FPS on the 7800 XT, all of them with 1% lows closer to 80, which could have been a little bit CPU related. Well, we're not mostly CPU limited here. This game's any performance issues you have in this game on a reasonably modern GPU is actually more likely a CPU problem, especially into more populated areas. I'm intentionally testing a less populated and less CPU bound area here since we're comparing graphics cards. Anyway, at 1080p Ultra, 130 FPS on the 4060 Ti's, 158 on the 7700 XT, and 7800 XT hitting 189 FPS. So yeah, they're all good for Baldur's Gate 3. How about Ratchet and Clank Rift Apart? 1440p, very high settings, no ray tracing at this point. Now we're seeing a game that wants more than 8GB of VRAM. And we're seeing a 21% performance improvement going up to the 16GB 4060 Ti over the 8GB version. And in the 1% lows, it's actually a 57% jump, so massive. Also, this game does seem to be a little more on the Nvidia side of things, performance-wise, although the 7700 XT still has a lead over the 4060 Ti 16GB. It's only by 7%, which is less than what we were seeing in a lot of the games. If we kick on the ray tracing at its maximum settings, so reflections, ambient occlusion, shadows, the distance turned all the way up to 10, now we're seeing the 4060 Ti's outperform the AMD GPUs, although the 7800 XT actually does slightly outperform the 4060 Ti 8GB version, but a little bit underperform the 16GB version. The 7700 XT is down at 37 FPS, and it's a 24% loss to the 16GB 4060 Ti. which is its closest price competitor here. Although it should be noted that none of these GPUs are hitting a 60 FPS experience until you turn on upscaling if you're going to be maxing out the ray tracing. So now that's what we're looking at here is DLSS and FSR2 at the quality preset with all the ray tracing maxed out. Now we're seeing the 8GB card can hit almost 60 FPS average, but its 1% lows are terrible, down at 25, and the game really wants a lot more than 8GB of VRAM. The 4060 Ti 16GB has enough and is hitting 77 FPS average and 54 in the 1% lows. And the 7700 XT is hitting 57 average, but only 29 in the 1% lows, and the 7800 XT is 77 average, 58 in the 1% lows. So we definitely want a lot of VRAM here, and it's a heavy ray tracing workload. If we go down to 1080p, very high ray tracing settings again, so still maxed out ray tracing. We see the 4060 Ti at 59 average, but 1% lows down at 36. The 4060 Ti 16GB gets a 24% boost from there at 73 average and 51 in the 1% lows. And the 7700 XT is 18% slower than that. It does average 60 FPS though, with 1% lows at 43. And we get a 22% bump up from there with the 7800 XT, averaging 73 and 51 in the 1% lows. And the 7800 XT is roughly matching the performance, actually just about almost exactly matching the performance of the 4060 Ti 16GB. If we go down to the very high settings without ray tracing enabled, you'll notice that the game actually just performs extremely well. And the GPUs are crushing it here. The 4060 Ti 8GB at 99 FPS, but even at 1080p very high, no ray tracing, the game wants more than 8GB of VRAM, and the 4060 Ti 16GB is able to jump up 27% performance over its 8GB counterpart, and the 7700 XT only beats that by 4% at 131 FPS, and we jump up another 27% to the 7800 XT past that point. Let's look at another game, Star Wars Jedi Survivor at 1440p maximum settings. This is epic with ray tracing enabled. We're seeing that only the 7800 XT is able to average over 60 frames per second here at 68 and 48 in the 1% lows. The 7700 XT is at 56 and is beating the 16GB 4060 Ti by 8%. And that one is only 1 or 2 FPS ahead of its 8GB counterpart. So while the GPUs will show more than 8GB of usage here, it seems like the 8GB card still handles it okay and isn't seriously underperforming its 16GB counterpart. Unclear if maybe there's a little more pop-in or some textures loading in late or anything like that, though. I didn't notice any in the footage. If we drop down to the high settings, though, rather than Epic with RT enabled, now the 4060 Ti cards are both averaging a little over 60 FPS, but we now get a 19% lead for the 7700 XT. So with ray tracing off, as expected, the AMD card performs better than it did relatively, with ray tracing enabled. And a 22% jump from there for the 7800 XT, hitting 90 frames per second. So very, very good performance here, especially with the ray tracing disabled and down at the high preset. By the way, I'm pretty sure this game just got a patch that added in DLSS, but again, I tested this in the first week of September, where that patch had not dropped yet. It was the most recent one prior to that, though. At 1080p with maxed out settings, so epic settings with ray tracing enabled, all the GPUs actually do very well. The 4060 Ti's are able to average in the mid-70s, and we get an 8% bump from there for the 7700 XT. So despite this being a ray tracing workload, the 7700 XT is beating the 4060 Ti 16GB by 8%, and the 7800 XT is beating it by 16% and is up around 95 frames per second. So in these lighter ray tracing workloads, the AMD GPUs still can take a lead, and if you turn the ray tracing off, here we're looking at high settings with no ray tracing, then we see a larger lead with the 7700 XT beating the 4060 Ti's by 19%, but they're all doing really well. The 4060 Ti's are hitting 99 FPS, the 7700 XT at 118, and the RX 7800 XT is at 142 frames per second, which is a 20% lead over what we saw from the 7700 XT at 118 FPS. So really 1080p high settings, these GPUs are all pretty much crushing it. Apologies for getting the Nvidia cards looking a little washed out in the footage. That was just a capture card setting. I think I had the color range, whatever that is, set wrong that day. Anyway, also happened in Resident Evil 4 Remake. And we're looking at the maximum preset, which does include ray tracing. Just some ray trace reflections in this game, and they honestly don't look that great. But anyway, with it on, we do see the game use more than 8 gigabytes of VRAM, giving a massive lead in the 1% lows. They're twice as good on the 16 gigabyte 4060 Ti versus the 8 one. But despite ray tracing being enabled, the 7700 XT is 15% ahead of the 4060 Ti 16 gigabyte. If we go down to the prioritize graphics preset, which does not include ray tracing, we now see that the game is not using more than 8 gigabytes of VRAM, so the 4060 Ti's are now tied, and the 7700 XT is 25% ahead of the 4060 Ti's. But we get an additional 20% gain from there for the 7800 XT, which is now hitting 140 frames per second, and all of them have good 1% lows now that the VRAM wasn't going over 8, but if we go to 1080p resolution but go back to maximum settings, we go over 8 gigabytes of VRAM again. So look at the 1% lows on the 8 gigabyte 4060 Ti, and it's a disaster, and the 16 gigabyte version does much better. The 7700 XT is 7% ahead of the 4060 Ti 16 gigabyte. Because it's a lighter ray tracing workload, it still takes a lead since it came from such a big lead without it, and a 20% boost for the 7800 XT from there. Now, if we go down to the prioritize graphics preset, which once again does not include ray tracing, all of the GPUs are doing well because once again, lower than 8 gigabytes of VRAM, so the 4060 Ti's are tied around 140 frames per second, and the 7700 XT is 19% of that, ahead of that at 166 frames per second, and then we gain an additional 19% on the 7800 XT at 197 frames per second. Now let's take a look at The Last of Us Part 1 at 1440p Ultra preset, and once again we're seeing a game use more than 8 gigabytes of VRAM, and the 4060 Ti 16 gigabyte takes a 17% lead over its 8 gigabyte counterpart. And this game does seem to be a good one for Nvidia, because the 7700 XT is, actually maybe not just Nvidia, but maybe this is trying to go over 12 gigabytes on the 7700 XT. I don't know, it seems rough here. It's tying the 16 gigabyte 4060 Ti, but then there's a 40% lead for the 7800 XT over the 7700 XT, which seems weird unless we were maybe going over 12 gigabytes of VRAM there. Anyway, if we drop down to the high preset, things look a lot more like we see expected scaling here with the 4060 Ti's tied because we're now not over 8 gigabytes of VRAM usage. We get a 20% lead for the 7700 XT over the 16 gigabyte 4060 Ti, which is more of what we kind of expect. And the 7800 XT has a 20% lead over the 7700 XT, which again is more in line with what we would expect. So again, it seems like the 7700 XT was just struggling with the Ultra preset at 1440p, possibly VRAM related. Anyway, if we go down to the 1080p Ultra settings, we're still a bit over 8 gigabytes of VRAM at times, which gives the 4060 Ti 16 gigabyte a 6% lead over its 8 gigabyte counterpart, but it's not too bad at 1080p. The 7700 XT takes a 12% lead over that, and then the 7800 XT takes a 17% lead over the 7700 XT. And again, this is at the Ultra settings. But what if we go ahead and drop down to the high preset? At high settings, we're once again not going over 8 gigabytes of VRAM, but the 7800 XT is hitting such a high frame rate. We're actually seeing the GPU usage down closer to the lower 90% range a lot of the time, and below that even into the 80s at times, which means that the 7800 XT is CPU limited here, which is why it only has a 5% lead over the 7700 XT, which in turn has a 12% lead over the 4060 Ti 16 gigabyte, and the 8 gigabyte card is basically tied with that. So yes, definitely seeing a bit of CPU limitation happening in this title. Now, let's look at Cyberpunk, and now while I try to test the latest games, this game does have some of the latest features. I'll take a look at frame generation here. This is ultra ray tracing, so I wanted to look at a super heavy ray tracing workload. DLSS and FSR2 at the quality setting, and you can see how they compare at those settings without frame generation. And then you can look at the settings with frame generation on. The problem is that generated frames aren't really the same thing as that frame rate achieved normally without generated frames, because the generated frames aren't responsive to user input, so it doesn't really feel the same, and there's a bit of a latency penalty. So whatever, I gave you both graphs, and we can probably talk about this a little bit more in the final thoughts section of the video. But yeah, I did want to show at least one test with frame generation enabled. Interestingly, at the Ultra RT with the upscaling enabled but no frame generation, it wasn't that big of a blowout for the 8 gigabyte 4060 Ti, and actually the 7800 XT was ahead of it, which I found kind of interesting. Anyway, we can go ahead and test out this same game, but at some other settings. So like, what if we didn't enable the upscaling? Well, in this case, they're all just doing terribly. So anyway, it's kind of, I don't know, is it sort of a moot point? Like, hey, look, they all perform bad. They're under 30 frames per second. Also, I didn't get the 16 gigabyte card retested in this game because I was actually originally not planning on including Cyberpunk in this video because I wanted to focus on the newest games, and it's really a few years old now. But anyway, I did also throw in 1440p ultra settings where it's like, well, what if you just didn't use ray tracing? The game still does look quite good. And now the 4060 Ti is able to hit around 60 frames per second, but the 7700 XT actually has a 31% lead over it and hits 80 FPS average through the built-in benchmark run, and the 7800 XT in turn is 21% faster than that and hits 97 frames per second through this built-in benchmark run. All right, at this point, we've seen a ton of performance. Let's get some final thoughts. All right, we've seen how they stack up, and in general, it was usually a bloodbath with the 4060 Ti's getting a severe beating. There were games where they could come out basically tied with the 7700 XT, although these were rare. We saw that in Layers of Fear. Sometimes we saw with a lot of ray tracing enabled that the 4060 Ti's could get some wins over the 7700 XT. Usually the 7800 XT, which is more expensive, was still kind of at least hanging in there, although could get beat in our heaviest ray tracing testing. Again, in some lighter ray tracing workloads, we still saw the 7700 XT ahead of the 4060 Ti models. So there was a lot going on here, and in a lot of games, the 7700 XT had a 20 to 30%, sometimes a bit more, sometimes a bit less, lead over our 4060 Ti's, including in big new engines like Unreal Engine 5, seeing a lot of 30% wins when we're at native resolution. So in general, the 7700 XT seems to be a good choice over the 4060 Ti models if it was in a vacuum. The other thing that we see here is that the 7800 XT is often winning by a good margin over the 7700 XT for only $50 more. If we scroll through again, a lot of these charts, we see that wins by 20%, 16%, 17%, 25%, 22%, 20%, 20%, 23%, 19%, 20%, 32%, 35%, 30%, 24%, 20%, 27%, 35%, etc., right? It's not at all uncommon for a 20% or greater victory for the 7800 XT over the 7700 XT. And if we look at a calculator here, it's $500 divided by $450, 11% more money to spend that extra $50 on the 7800 XT. So in the $400 to $500 price class, it certainly seems like the 7800 XT is by far the value proposition leader, but that doesn't mean everybody can stretch to the $500 price point. It just means if you can stretch to the $500 price point, it certainly looks like the 7800 XT is worth spending the extra money to get there out of these competitors. Now, as far as a couple of things going on here, let's look in the actual pricing in the current market on all of these. It looks like 4060 Ti 8GB cards are still mostly at $400 and up, although we do see one MSI Gaming X model down here at $384. The 16GB models are coming in, it does look like, at their $450. At least I see one model available at that price point, but still many of them still at $500, which if you really wanted to look back at this data as the original price of the 4060 Ti 16GB, which was $500 up against the 7800 XT, well, then it's usually still a dominant victory even with ray tracing enabled for the 7800 XT over the 4060 Ti, 16 gigabytes. So yeah, definitely don't go up into that $500 price point where a lot of them are still sitting on those 16 gigabyte models. The 7700 XT is looking like it's widely available at its $450 price point. But one problem I'm running into is that the 7800 XT is not looking to be widely in stock after its launch. It seems like this one actually mostly sold out. I'm only seeing on PC Part Picker one model available, and it's marked way up. If I go somewhere like Newegg, sorry if I just blinded you, we do see that some models are available for $500 at a back order, specifically stating this product is temporarily out of stock because of high demand. We will replenish it as soon as possible. If I scroll down again, yeah, most of these 7800 XTs are looking sold out. By the way, the specific model I was testing in this video is the Red Devil. And the 7700 XT I was testing is the Power Color Hellhound. And thank you to Power Color for sending those models over for the testing here. If you're interested, the 4060 Ti 8GB version I have is the Founders Edition, and the 16GB is the Gigabyte Gaming OC. They were all run at their out-of-the-box settings with ResizeBAR and Smart Access Memory turned on my 7800X 3D platform. You can check the video description for the full platform and all that. Anyway, so basically, it looks like the 7800 XT is the best buy here, although we're going to have to wait for stock to come back in because it looks like people recognize that as being the best buy. The 7700 XT in a vacuum of no competition from the 7800 XT doesn't look too bad at $450 up against the Nvidia models. However, I should mention that the 6800 non-XT from AMD's previous generation also gives you similar performance with 16 gigabytes of VRAM instead of 12. And also, sometimes that does matter. For example, I have a test right here at Last of Us Part 1 with 1440p Ultra settings, where we do see the 6800 take a 14% lead over the 7700 XT, and that's most likely explained by pushing right up against that 12 gigabyte of VRAM buffer, and we see some system RAM increased usage on the 7700 XT, showing that that does look like a VRAM issue. And I do plan to break out this comparison with where I tested all these same games again at a huge number of settings, all of that, as its own separate video as well. If you're looking at that, because I know that one's a little more situational in your market, because the 6800 in the US market right now, I can see as low as $420, still brand new. If you're willing to look used, you can get it less than that. But around the world, I know that some of the 6000 series availability has already dried up, and I expect to see the availability drying up, in other markets like the United States here as well. Yesterday, I saw one as low as it was like $399, yeah, $400 even. But it looks like that one did sell out when I posted it on my community page. But again, you can be looking for those types of deals. The 6800 XT looks like coming in at $500, and this gives you very similar performance to the 7800 XT, and would be an interesting option if the 7800 XTs are in fact sold out at this point. But again, we would hope to see the stock replenishing on that as we go. And again, the 6000 series I would expect to see eventually dry up on availability. One thing with the 7000 series, though, over its 6000 series previous gen competitors is AMD does currently have some exclusive features to the 7000 series, with HyperRX, for example, the most interesting part of that currently being the Anti-Lag Plus, which gets you a bit more latency reduction in incompatible games than their older anti-lag technology, which was available in all games through the driver level. Anyway, so there are some advantages to the 7000 series AV1 encoding, for example, if you stream to YouTube or something like that. But in general, I thought in the GPUs from the current generation that we took a look at in this video, my overall thoughts are the 4060 Ti's are for the most part getting embarrassed. The 7700 XT looks good versus them. But then just kind of looks like, hey, if you could spend the extra $50, buy yourself a 7800 XT instead. And the last thing I should mention is, okay, but what about frame generation? That's kind of the big difference right now. Is that the secret sauce for these 4060 Ti cards? All of that. Well, again, it's the one test I ran with it here was in Cyberpunk. One reason I didn't do more testing with this in this video is because we're expecting FSR 3 to release in, well, AMD said early fall in games like Immortals of Aveum and Forspoken initially, but then they had at least a dozen game developers with support, on the way, that kind of a thing. Anyway, we're seeing that, yes, with frame generation and heavy-duty ray tracing workloads enabled, the 4060 Ti's can take a bit more of a lead, but you should also be aware that, the frame rate number with when it's achieved through frame generation doesn't really equal the same experience you would get when you achieve that frame rate number without frame generation. For one thing, the game is not as responsive because the generated frames are not responsive to user input, and the game slightly delays showing you an actual normal game frame in order to give you that frame. And then also it can introduce some image quality artifacts. In some games it looks very good and very usable. In other games it's not. Also not supported in every game. So basically you would use this in single player games that support it, which isn't all of them. And again, the higher your base frame rate, the better it feels from a responsiveness point, and the better it looks. In this test here with 1440p RT Ultra in Cyberpunk, using DLSS quality to upscale and kicking on frame generation, we can see that DLSS quality only got us into the mid-40s, kind of low 40s in this scene, on the 4060 Ti 8GB. So then kicking on frame generation does get you past 60, but you have a fairly low base frame rate, so the image quality and responsiveness aren't going to feel great. Also, on the 8GB GPU, we can have a bit of stuttering happen here, which you can see on the frame time graph at times, with the frame generation taking a bit more VRAM, and you can get a little bit more spiky on the frame time graph than you get on the other GPUs. That kind of thing. Anyway, I'd really like to wait a bit more on frame generation comparison here until we get FSR 3 as the good head-to-head competitor. But for now, rather than buying features that aren't out yet, yes, the 4060 Ti does have access to frame generation, which can be a cool, useful feature in situations, like I said, where it's supported, where you're getting, I'd prefer at least a base frame rate around 60. So in this case, I feel like the heavy-duty ray tracing at 1440p at least is a bit too much for it, and maybe not giving the experience I would want anyway, despite if you just look at the frame rate numbers, it does give it a large lead here. Anyway, that's kind of one of the problems with the 4060 Ti's is that in general, if they, the one thing that they can kind of do better than the AMD competition in this price range is extremely heavy ray tracing, but they're a little bit weak for that, is kind of the problem. The other game, heavy ray tracing game I tested here was Ratchet and Clank. And again, the 8GB model wasn't really better than our 7700 XT and our 7800 XT, and the 16GB model had a bit more of a lead, but still it wasn't absolutely massive. Like were you getting the experience that you really wanted anyway? And then when you kicked on upscaling in order to get there, then the 7800 XT actually competed fairly well against it. So again, if you can stretch up to that $50 more on that 7800 XT, it certainly seems another situation where that seems compelling. If you're interested in the 7800 XT, and then, okay, what if I went up another $100 from there to something like the 4070, which maybe is strong enough to do more of the heavy ray tracing, that kind of a thing. I did a whole dedicated video on that topic. I think I've gone on and on enough with my final thoughts here. Basic summary is the 7700 XT looks good against the 4060 Ti's, but try to spend $50 more on the 7800 XT if you can get it available at that price. It does look like it had a lot of interest and did sell out on the initial launch wave. I hope all of you have an excellent day.